Open up your MTT, and now we're going to solve graph and set builder notation with absolute value equations and inequalities. So the first thing that we're going to do is change our absolute value equation into two equations that we can solve. So we're going to go ahead and break it down. We're going to copy it exactly the way it's written first. X plus 7 is equal to 3. And then we're going to do x plus 7 is equal to negative 3. Because we know the absolute value of 3 could be 3, but we also know that the absolute value of negative 3 could be 3. So inside the absolute values, we can have a positive 3 or a negative 3, so we're going to solve. We're going to go ahead and zero pair out the 7, so x can equal negative 4, and zero pair out the 7, and x can equal negative 10. So if we do the mental math, we do negative 4 plus 7 is positive 3, and the absolute value of positive 3 is 3. We can also substitute in negative 10. So negative 10 plus 7 is negative 3. The absolute value of negative 3 is also 3. So we have this on our graph. We're going to go ahead and put our 0 in, our negative 4, and our negative 10. And because this is an equation, we're going to only have 2 points graphed. And so for our solution set, we're going to simply list the 2 points that are graphed. And so we don't have set builder notation because we just have 2 points that are graphed. Alright, now let's try an absolute value with an inequality. So again, we're going to write this into 2 equations. This is going to be x minus 3 is greater than or equal to 1. And now when we write our second one, x minus 3, we're going to use the mega minus man because he is going to not only change the sign, but he's also going to make this a negative 1. Now we're ready to solve. We're going to zero pair out the 3. And we have x is greater than or equal to 4. And zero pair out the 3. We have x is less than or equal to 2. So now we're going to go ahead and we're going to graph. And because it is a greater than or less than, we're going to put both of them onto our solution set graph. The sign in the original problem tells us because it is a greater than or equal to inequality, this is going to be an OR graph. So that's what we're going to anticipate when we go to graph it. This is 0, 2, 4. So we have x is less than or equal to 2. So closed in circle, going to the left. And x is greater than or equal to 4, closed in circle, going to the right. So when we go to write our set builder notation, of course we have to do it with the smallest number going first. So this is going to be x is less than or equal to 2, or x is greater than or equal to 4. Set builder notation. Now we have a less than inequality that we're going to solve. So we're going to set it up the same similar way. Break it down into 2. 2x plus 1 is less than 5. 2x plus 1. We're going to use our mega minus man, flip the inequality, and flip the sign of the 5. Now we're going to solve. Subtract 1. So 2x is less than 4. Divide by 2, divide by 2. X is less than 2. Zero pair out the 1. We have 2x is greater than negative 6. Divide by 2, divide by 2. X is greater than negative 3. Now, because this was a less than problem, this is going to be an and when we graph it. So let's see what it looks like. So this is going to be 0, -3, and x. So we have x is greater than -3. Oops, not x. This should be 2. And x is less than 2. So you'll notice that it's in between. So we put our x, our -3, and our 2. X is less than 2, and x is greater than -3, set builder notation. All right, so now we have a greater than or equal to. So when we have a greater than or equal to, we know that it's probably going to be an OR graph. So we're going to break it down. 5 minus x is greater than or equal to 3. And then we're going to do 5 minus x, mega minus min, is less than or equal to -3. And we'll solve. 0 pair out the 5. We have -x is greater than or equal to 8. Divide by -1, divide by -1. Now you notice that we have minus min showing up. So we're going to have x is less than or equal to -8. Okay, now we're going to 0 pair out the 5. And we have -x is less than or equal to -8. Divide by -1, divide by -1. Again, we see the minus min appearing. So we're going to flip the sign. X is greater than or equal to 8. So we're expecting an OR graph. Put our 0 in. -8, +8. X is less than or equal to -8, so it's going to be a colored in circle going to the left. Colored in circle for the 8 going to the right. It is an OR equation. So for our set builder notation, we're going to write the OR. And there we have it. Now you're going to be given the graph, and we have to figure out what the absolute value equation is that is graphed. So the first thing that you want to do is find the middle of the graph. So if we start with the 11s, and 1, and 8, and 2, 9, and 3, 8, and 4, 7, and 5, our middle of the graph is a 6. So we're going to write our absolute value. Because it's a positive 6, it's going to be a -6 inside the absolute value. And then what we're going to do is we're going to count how far it is from the 6 to the 2 endpoints. So this would be 1, let's make some dots, 1, 2, 3, 4, 5. And when we check it on the other side, again we have 1, 2, 3, 4, 5. So we know the 5 is outside. Let's put our x inside. Now, because we have 2 endpoints and it is an and, we know it's a less than. So that is the absolute value equation that is graphed on that graph. Let's try another one. So now what we're going to do is look at the middle of the graph. So we're going to go from the endpoints and we're going to go find the middle. So we'll start at the 2 endpoints, and here is our middle. So we put our absolute value in, x. This is a -4, so we're going to take it and make it +4. And now we're going to count to see how many steps it is to get to the 2 endpoints. So we go 1, 2, and 1, 2. So we know the 2 is going to be here. It's an OR, which means it must be a greater than, and it's also got open circles, so we know it's just greater than. All right, now let's look at this one. So now we need to find our center again. So we're going to start with our endpoints. So we have the two endpoints, 1 and -7, 0, -6, -1, -5, -2, -4. So there's our endpoint, our middle point. So now we're going to take our absolute values, x. It's a -3, so it's going to be +3. And now we're going to count from -3 to the two endpoints. So we've got 1, 2, 3, 4. 1, 2, 3, 4. So we know this must be a 4. Now it's an or, which makes it a greater than, but we also have colored in points, so we know it's greater than or equal to. Okay, last one. Again, we're going to find our middle point. So 6, -2, 5, -1, 4, 0, 3, 1. So our middle point is a +2. So inside the absolute values, we have x -2. We're going to count 1, 2, 3, 4. 1, 2, 3, 4. So we know the 4 is outside. It's an and, so it has to be less than, but because the endpoints are colored in, we know it's less than or equal to.